All right, let's look at the homework 3.7, problem number 4. All right, so we have this function y equals x times square root of 36 minus x squared. All right, so let's find x-intercepts. All right, so x-intercept, we set y equal to 0, so it's actually pretty easy to do it. We can probably do it in our head. All right, so we set this y equal to 0. So x equals 0 is one of them. We have to find 3 of them, so that will be probably the middle one. So if x is 0, of course y is going to be 0, right, because x-intercept. So actually all of them has a comma 0, right? So you have a comma 0. So we have to find the x value here. All right, but we can make 36 x squared equal to 36. So x is a plus or minus 6. So it's going to be negative 6 is the smallest one, and the largest one is plus 6. Right, so that's the x-intercept. Y-intercept, we set x equals 0, but if you put x equals 0, y is 0 too. So it's going to be 0, comma 0. Right, let's check the answer. All right, I came back and looks like we got the intercepts correctly. Right, so let's find the relative maximum and the relative minimum. Right, so let's do that. To do that, we need to find the derivative and the critical number. So let's take the derivative. All right, so y prime is equal to, right? Actually, before we do that, I'm going to rewrite this guy as x times quantity 36 minus x squared raised to the 1/2 power, right? All right, so derivative is going to be derivative of the first guy, product rule. So 1 times the second, so you have a 36 minus x squared raised to the 1/2 power. All right, plus first guy is x times derivative of the second guy, so it's a 1/2 in front, and then we have same inside function, so 36 minus x squared. Subtract 1 from the power, so it's a negative 1/2, and multiply by derivative of the inside, which is derivative of 36 minus x squared would be negative 2x. All right, so we have that. All right, then let's see, we can cancel out the 2 on the bottom and then 2 on top, so you can cancel those. All right, then I'm going to just rewrite it. All right, so first thing, actually 1 doesn't do anything, so I'm going to go ahead and scratch that out. All right, then you have first term is simply 36 minus x squared raised to the 1/2 power. Right, and I'm going to write this guy as the fraction form. So we see that there is, let's see, there's a negative sign right here, right? So it's going to be negative, minus. Right, then you have on top, we have x here, and you have another x. So it's going to be x squared on top. So I'm going to put x squared on top. All right, then since we have a negative power, we know that the quantity 36 minus x squared is going to be downstairs. So I'm going to put that quantity 36 minus x squared. All right, then we still have 1/2 power sitting right here. So I'm going to have to put 1/2 power right here. All right, so we got that. All right, then I want to combine these together because I don't want to deal with 2 separate terms. So I'm going to put the find the common denominator. So common denominator is going to be here quantity 36 minus x squared raised to the 1/2 power. Right, but we're going to have to do exactly the same thing on top so that we don't change the quantity. All right, so we get this. So the denominator would be, so you have a common denominator. So you have 36 minus x squared to the 1/2 power. So it's the same denominator there, right? So we have a common denominator. Right, so you have 36 minus x squared raised to the 1/2 power. All right, then if you multiply these two guys together, right, so because this is basically a square root of 36 minus x squared by itself, so you're going to get the 36 minus x squared from there. All right, then we have a minus, right, so here's a minus sign, so we have to subtract. Right, then you have x squared on top, right? So actually, can I just write it as instead of x squared minus x squared, there are two of them, so it's a minus 2x squared. So I'm going to just go ahead and erase that. And a minus 2x squared. All right. Then since both of these numbers are even numbers, I'm going to even pull 2 out. So this is going to be right, 2 is outside, so 36 divided by 2 is 18 minus just x squared because 2 is pulled out. And then denominator is 36 minus x squared to the 1/2 power. All right, so let's find a critical number. Critical number would be we set this guy equal to 0, right? So you can see that, let's see, we have to make sure that the numerator has to be 0. So we know that x squared has to be equal to 18. And then we can just take the square root of both sides. X is equal to plus or minus square root of 18. Right? That which is the same thing as what plus or minus 18 is, let's see, 9 times 2, so 3 times 3 times 2, so 3 square root of 2, right? All right, so we need to do the increasing decreasing analysis as usual. I'm going to just draw a number line here. All right, then let's see, critical numbers are negative 3 square root of 2, or square root of 18, and then positive 3 square root of 2, right? And you can see that the domain of this original function is between -6 and +6, right? Because if you go beyond -6 or +6, you're going to get a negative number inside the parentheses. So you actually, it's restricted to -6 to +6. All right, so we got that. And then what we want to do is do an increasing, decreasing analysis. All right, so let's try that. So we have, let's look at the y prime. Right. So any number between -6 and -3 square root of 2. This is gonna is a tough one. Let's see. But -5 would be, let's see, -5 is a square root of 25. So it is smaller than square root of negative square root of 18. So I'm going to try x equals -5. And between here, I'll use like 0, right? And here I'm going to use 5, right? All right, let's look at the sign. All right, so if you plug in -5, all right, so let's look at this expression here. Because of the square root here, this is going to be always positive here, right? So if you plug in 5, you have, let's say, -5 squared, so 18 minus 25, so it's going to be negative here. So it's going to be derivative is negative there, right? If you plug in 0, 18 minus 0 is positive, so you're going to have a positive sign there. Right? If it's +5, 18 minus 25 again, so we know that this is going to be negative there. So we know that there's a negative sign there. Right? So we know that y function, original function, is decreasing here and increasing here and decreasing there. All right, so we know that looking at the shape, we know that here we're going to have a local. You're going to have a local minimum there because you're looking at the bottom of the valley. Here is the local maximum. All right, we got that. All right, so let's type it in. All right, so local maximum at, let's say, 3 square root of 2, comma, we have to find the corresponding y value, we'll do that, and negative 3 square root of 2, right, comma. All right, so let's type it in. So what would be the function value? All right, so it's going to be y is equal to, oops, I'm going to use, right, so I'm going to plug in, say, negative 3 square root of 2, which is square root of 18. All right, so this is going to be negative square root of 18 times square root of, let's see, 36 minus 18 is actually another 18. So this is actually negative 18, right? So if you plug in positive square root of 18, right, that's the other one, so that's going to be a local maximum. And it's a square root of 18 times, again, square root of 18, right? So it's going to be positive 18. All right, so we have relative maximum is going to be 3, 2, and then 18. And for the local minimum is going to be negative 18 there. All right, let's check the answer. All right, I came back and looks like we got the local maximum and the local minimum correctly. All right, so let's look for a point of inflection. All right, so we need the second derivative, so we're going to have to take another derivative here. All right, so if you take another derivative, let's see, maybe I'll go down here, y double prime. All right, so let's work on, let's see, probably this is probably the good one to look at. So this is the first derivative. All right, first I'm going to pull 2 out. So 2 is outside, so I don't have to worry about it. So this 2 is already taken care of. All right, then we just have to take the derivative of the rest of it. Maybe I'll just, so we just have to take the derivative of this part right here. All right. So I'm going to just put up a big curly bracket or something so that we can just separate 2 there. All right. So it's going to be a quotient rule again. All right. Square the bottom. This is kind of nice. So it's a square root. It's going to be, if you square that, you're just going to get the 36 minus 8x squared. All right. And 2 is already taken care of. So we take the derivative of the top, which is negative 2x. Multiply that by the bottom, which is 36 minus x squared to the 1/2 power, and minus top, which is 18 minus x squared, multiply by the derivative of the bottom, which is, let's see, 1/2 in front, and then keep 36 minus x squared as it is. Subtract 1 from the power, so it's a negative 1/2. Multiply by derivative inside, which is negative 2. All right, so, sorry, negative 2x. All right, it's a little bit hard to see. I'm going to just rewrite it so that we can see it better. All right, so this is negative 2x sits there. All right, so that's the derivative. All right, so let's simplify this. So we have, let's see, we're going to cancel out. There's a 2 on the bottom and 2 on top, so you can definitely cancel that. All right. Then what I'm going to do is, since I don't like having this negative power here, so I'm going to multiply top and bottom by 36 minus x squared to the 1/2 power. So I'm going to multiply by, so I'm going to, so it goes here. All right, there's no room. We're going to multiply by 36 minus x squared to the 1/2 power over, same thing, 36 minus x squared to the 1/2 power. Right? So if you do that, you're going to get this. Right? First, I'm going to pull out something in common. So let's see, we have, there's going to be maybe a negative sign here. Negative x, how about that? Negative x. All right, so there's a negative x there. So I'm going to pull it out. So it's going to be a negative 2x is pulled out. All right, then do this. So if I distribute 36 minus x squared to the 1/2 power to the first term, you're going to get simply 36 minus x squared. Right? So that takes care of this guy. Right? And if you distribute this guy here, since this is just a reciprocal, and this guy will simply cancel out. Right? And then what's left would be, right? So you have a negative 18, so you have a minus 18 here. Right? And then you're going to have, let's see, I'm missing something here. So it's a negative 18 and a plus, right? And x squared, right? Sorry, I forgot something here. There was actually 2 here, right? So I have to actually put the 2 times 36 minus x squared. Sorry about that. All right, then we took care of negative 18 and then positive x squared. So we have those guys already taken care of. All right, and then the denominator is simply, so this is going to be a first power and a 1/2 power. So it's going to be 36 minus x squared to the 3/2 power. All right. All right, if you clean this up, you're going to get, let's see, you have a negative 2x, all right, in front. All right, you're going to have, so you have, let's see, 2 times 36, let's do this. 2 times 36 is 72, minus 18 is 54, so we have 54. All right, so that's just these numbers here. All right. Then here we have negative 2x squared plus 1x squared. So if you distribute here and combine with x squared, so you're going to get the minus x squared. Right? And the denominator is 36 minus x squared to the 3/2 power. Right? So if we set this guy equal to 0, we see that, let's see, x is going to be equal to, right, numerator equal to 0. So x equals 0, and here, square root plus or minus square root of 54 will make this guy equal to 0, right? But you have to be a little bit careful, though, because the domain of the original function is between negative 6 and positive 6. These are actually too big, so we cannot include these. All right, so it looks like if there's an inflection point, it's going to be at the x equals 0. We can make sure that that happens there. All right, so I'm going to do a number line again. So this is going to be again between negative 6 and positive 6, and then we put a tick mark for 0 here. All right. Then we just look at the sign of y double prime. All right. So any number between negative 6 and 0, so I'll try negative 1, and try anything between 0 and 6, I'll try positive 1. All right. Then we're going to check the sign. All right. All right. Here, this guy has, let's see, it's going to be, so you have a square root there, so this is never negative. So this is going to be always positive on the bottom. All right. So if you plug in negative, a negative 1 here, so you have a negative 2 times x is going to be negative. All right, so this is negative. All right, negative 1 squared, so this is going to be positive. All right, so you have a negative times positive will be positive, divided by positive is positive. All right, if you do a positive 1, so this turned into positive sign, that's still positive, so this is going to be negative. So we know that the original function, right, positive second derivative, we know that it's a concave upward. Negative second derivative, we know that concave downward, right? Since there is a concavity change, so we know that there's going to be an inflection point at x equals 0, right? So if you plug in 0 for x, so y of 0 would be, right, obviously 0. So inflection point is the origin, right? So let's type it in. Right, so inflection point is 0, 0. Right, let's check the answer. All right, it came back and looks like we got the point of inflection correctly. Right, horizontal asymptotes. Right, so this is kind of tricky, but since the domain is restricted between -6 and +6, it cannot have a horizontal asymptote because we cannot take a limit at infinity. Right, so answer is does not exist. All right, and vertical asymptote, there's no vertical asymptote either because there's no fractional form. So it does not have any number that makes this guy blow up. All right, so it's going to be does not exist. All right, let's go ahead and check the answer first. All right, I came back and looks like we got horizontal asymptotes and vertical asymptotes correctly because they don't have any. All right, so let's find the correct picture. So what do we know? We know that the x-intercept, y-intercept is zero, and x-intercept there are 3 x-intercepts, and the relative max at 3 square root of 2. And the relative min at x equals -3 square root of 2. Alright, so here this one doesn't look like it. This one, the second one doesn't look like it. It looks like you're gonna have a 2 minimum. Here there are 2 maximum, so this should be the correct picture. Alright, so you have a minimum there, a max there, and the inflection points. And let's see, we know that, yeah, so that's that, and